about a month or a month and a half ago, I switched companies and roles. I used to be a data analyst, and now my title is data scientist, associate data scientist. But my job is really more like data engineering. So I want to break down what all these three data roles are, because it does sound synonymous, but actually they're just different flavors of data science. So yeah, as you can see, next to each of these roles, I have an icon, and that is to help make the understanding a little easier. So for data analysts, they're storytellers; data scientists, they're the influencers; and data engineers, they're the coordinators. As a storyteller, your main focus is to be able to translate numbers, data, facts into a compelling story. So a story has a beginning, a middle, and an end. And that is up to a data analyst to figure out how they want to write their story, but it generally follows that flow. And they're typically communicating to stakeholders, so they're the most front-facing people. Data scientists are kind of in between. They are not fully front-end. They could be front-end if there's no data analyst within their department. They might act as a data analyst / data scientist. This is where they can be full front-facing. But they also are a little bit doing back-end with the models and predictions and KPIs. And data engineers are very much back-end. They don't really talk to stakeholders. But they do talk to data scientists and data analysts to figure out how they can make the data analysts and data scientists' lives easier and better. So that's why they're the coordinators, because they basically make sure that the infrastructure works and runs smoothly for people downstream. And yeah, it's the least flashy role of all of these. And then for specialty, these again are just my opinion of what each flavor data person specializes in. So for data analysts, it's communication, business knowledge. Obviously, all three should be competent communicators, but data analysts are especially good with communication because they need to be able to talk in a language that's outside of the niche. If they're talking to a stakeholder or a prospect, they need to be able to speak non-technical language and convey the knowledge with the knowledge of data science. So this is where business knowledge is really helpful, because if they know the business well, then they're able to anticipate maybe the needs of the stakeholder and write a story that's compelling to the audience. Data scientists specialize in creating models, creating predictions based on it could be on different algorithms, and obviously it has to fit the business case as well. And they also are the arbiters of KPIs. So yeah, the reason I say they're influencers is because KPIs are kind of like grading rubric. And if they set the standard and they get to define whether you're above or below the standard, then they get to really influence the direction that the business takes. Data engineers specialize in building, maintaining pipelines. So think of a pipeline as like a train. You need to make sure each cart, is running and one follows the other. So it's about sequencing of things. And yeah, they're coordinators because they got to make sure each unit falls in line, and they also have to consider if a certain unit doesn't run, does that impact the units down the line? So that's my best definition of pipelines. They deal with big data and cloud. So they also do a little bit of like data maintenance, data security. So yeah, again, they just need to make sure that everything runs smoothly and efficiently. And so for example, the way that they support data scientists is if a data scientist has a model that they created and they have tested it, and they would like to scale this to more than just one specific case, they might want to scale it to, I don't know, bigger set of data or a different project or a different part of the greater industry, then this is where data engineers are really helpful, because they can basically take your model and template it and then be able to use that template to reproduce your model and then create this template where you can change the pieces that need to be modified, and boom, you just went from one model to 10 to 100 to 1,000. So yeah, let's just keep going. For their jobs, what they're mainly tasked with, now again, this isn't like the perfect, you could be doing hybrid of these. You could be doing more than what I have written here as well. I'm just going off of like my experience. So as a data analyst, I was mainly focused with creating visualizations and reports. So I think of it as like web development, except instead of creating a website, I'm just creating interactive dashboards for our stakeholders. Again, that's very front-facing. And then data scientists, they use math and machine learning and leverage that to create models and predictions. And data engineers do software development for data science, not like commercial use. Okay, so you know how like you probably use Microsoft in school or at work or personally. So that's software development. They're creating a software for like an ecology of apps for you to use. And we are not doing that for the bigger population. We're just doing it for specifically people downstream. So downstream for us is data scientists, data analysts. And we also work with automation, because you could, single-handedly click run my model. But if, let's say, you have so many models and each model is robust, you're actually wasting more time by not automating it. And so, yeah, we help data scientists deploy their models, help them automate kind of the full process of the project, and monitor. So this is where the CI/CD pipeline comes in. So yeah, again, we're coordinating. We're just making sure things run smoothly. That's it. And lastly, here are some of the tools that you might encounter or should have when you're applying for these roles. But it's not an absolute. You don't have to have all these roles as you're applying, because some of these tools you will learn on the job. So, for example, as a data analyst, you should, at the very least, know how to work with Excel, not just like beginner level. I mean intermediate, advanced. Know your H lookups, X lookups, V lookups. Know how to use flash fill. You know how to use conditional format. Know how to work with query and what's it called? That table. I'm already forgetting it. Oh dear. Pivot table, yes, okay. Things like that. That's like minimum. Then it's nice to have VBA, but if you don't have VBA, it's fine too. VBA helps with like scripting macros and things. Honestly, I never used VBA. I had a coworker who was really good at VBA. But in my experience, macros suck. They break down a lot, so instead I use Python. And I just think Python is so much stronger as a scripting language. Python is a multi-purpose language, but scripting is one of its functionalities. We should also get to know SQL. If you know SQL, that's very good. But if not, it's all right. You can learn on the job. And your role might not even require SQL, depending on how big your data is. But typically, bigger companies with more data keep their data in like data lakes, data warehouses, data bases. Yeah. So with database, that's what SQL is specifically for. You can talk to the database, get what you need out of it, filter your table, filter your view, and then from there you have a nice little table that you can just shove into your visualization program. And for visualization, I worked with Tableau and Power BI. There are alternatives like Cognos, which is IBM's. I've heard of Looker. There are some more visualization tools, but these are kind of standard. Power BI comes with Excel or with Microsoft. And for data scientists, again, they need to know statistics and advanced math, and they need to know coding. Python is really good for machine learning. R is specifically for statistics, and SQL, again, you're talking to the database. SQL is just kind of unavoidable if you want to get into data, no matter what role you're in. And then for data engineers, it's coding. So in my research, it looks like Java, Python, R, and SQL are the main ones. I don't personally work with Java. I use Python, R, I don't use R for work. I use R for fun. I use Python SQL at work. Yeah. And that concludes the different flavors of data science. I hope it made sense.